Hey everyone, and welcome back to my channel Binary Hath. Today I am diving into model context protocols building blocks. In my last three videos, I explained you on how widely MCP has been accepted in AI domain and it has a solid community support. In second video, I showed you that there are thousands of models present on Hugging Face, which are ready to use. In my third video, I covered the overall workflow for MCP integration. Now let's get into little deeper by exploring composition of model context protocol. MCP composed of three parts: the host, the client, and the server. Let's understand role of each one of them. But before that, does it remind you any architectural pattern? That's right. It is a client-server architectural pattern. MCP is based on client-server architectural pattern. Let's understand the host part. The host, this is your AI-powered application like an AI enhanced ID or sophisticated AI assistant. This is where your query to LLM starts. During development, you can have, say, your Visual Studio Code acting as the host. This will help you to build and test your AI integration. You just have to put some configuration in Visual Studio Code and it will get readily connected to MCP server. And that's the beauty of MCP protocol. Second component is the client. It is embedded within the host. The client is responsible for establishing and managing connection with MCP server. Both MCP server and client, they are following a standard. So they understand each other and can communicate using protocol. The client help LLM to get list of all tools and resources so that LLM can decide which is the appropriate tool for the query and its context. The third and the most important component is the server. These are independent processes that expose specific capabilities acting as gateways to data sources, tools, and prompts. You may choose to use open source or private source MCP servers for your specific use case, or you may write your own MCP servers. Data sources for the server can be local files, remote APIs, databases, or anything you want your AI to interact with. I mean your backend applications backend also backend database API platform. This enables LLM to expand its capability to application specific features or get access to real time information. MCP server acts as a bridge between external capabilities and large language model. Now let's explore more on the MCP server. As it is as it is doing all the external heavy lifting, it has to be well structured. Each MCP server provides three primitives that the AI can leverage, and these primitives are tools, resources, and prompts. Let's understand tools part of MCP server. Tools of the MCP server are executable functions that an AI model can call to perform actions. Imagine an MCP server for your email. You may use your smart AI assistant to respond to emails with formatted text. For example, tools could be functions like send email, analyze email, summarize email, list unread emails, or search emails. The AI simply requests the tool and the server handles the underlying API call. Resources are read-only data sources that provide context to the AI model. If you are aware of REST GET method specifically, then it is the same functionality offered under resources. You can put all your get calls under resources. Its scope is limited to getting the information or data to help AI generate accurate response, because now it is having a real time information in its hand. Resources could be a file on your computer, a record in a database, or even a live feed of stock prices. The AI can dynamically query all the resources to get up to date information. Since your AI is now able to get the real time or latest information, its responses will be more trustworthy. MCP allows servers to provide predefined prompt templates or workflows. These predefined prompts lets AI decide which is the most suitable prompt in the context of user query. LLM can then select the appropriate tool and get relevant information or perform the relevant action. And this means the AI can intelligently select and utilize the most effective prompts for a given task, ensuring consistent and high quality interaction. Let's understand this with an example. Let's imagine a real world scenario. Your AI assistant need to summarize yesterday's meetings and send action items to the relevant team members. Without MCP, you would need custom integration for your calendar service, your meeting transcription service, and your email client to send an email. Each would require specific API calls and data formatting. Get all meetings from your calendar server, transcript of each meeting from transcription server, and generate action items based on the information present in the transcript to create appropriate email response and send it using email client. Integration with these servers can be custom integration, as I mentioned, directly using exposed APIs of each server. However, this custom integration will be kind of non-flexible and hard to maintain because it is specific for your organization. But with MCP, it's seamless. The AI acting as the host connects to an MCP calendar server to get meeting schedules, an MCP transcription server to get meeting notes, and an MCP email server to send out those action items to respective team members. Of course, AI or your large language model plays an important role of creating an appropriate response. Import, Important point to be noted is that the AI simply requests the necessary tools and resources, and MCP handles the complex wiring behind the scene. This allows the AI to become a truly agentic system capable of autonomously pursuing goals and taking actions. Your smart application or assistant is now sending your command or query to LLM, and LLM, with the help of MCP client, identifies the most suitable tools and resources which MCP servers are providing. This will help LLM to generate an appropriate email response. This is part of the host and then MCP server. For respective capabilities, perform the task like reading information from calendar server, transcription server, get it analyzed from LLM, and get the formatted final response from LLM to send the email with action items to respective team members. We are separating the concerns over here. Please understand there is more active processing goes in the host part and the server part. I have just simplified it for the sake of understanding. I will cover more low level details maybe in specific video on MCP architecture. With that, I will stop here. I hope you got the complete idea on different parts of MCP client and server and how it carry out any kind of query or the prompt which you give to your LLM and execute it with external capabilities or get the information from the external capabilities. If you found this explanation and content helpful, please give me a thumbs up by pressing the like button and subscribe to my channel for more content on AIML. In my next video, I will be talking about MCP key benefits. Thanks for watching and I will see you in my next video.